Good morning, ma'am. My name is Tirthika. I'm from ACB section from second year. Today's my topic name is four basic feedback topologies. Introduction to feedback topologies. Feedback topologies are essential for controlling system stability and performance. There are four basic types of feedback configuration used in varying engineering systems. Understanding these topologies helps in designing more reliable and efficient control systems. In these four types of topologies of feedback amplifier, voltage series feedback, current series feedback, current shunt feedback, voltage shunt feedback. These are four types of feedbacks or another names for four types of topologies in amplifiers. Series shunt feedback, series feedback, shunt feedback based on the type of sampling voltage per current at output side. Based on this typing mixing series per shunt to the input side. In feedback topologies, there are four feedback topologies. They are voltage series feedback, voltage shunt feedback, current series feedback, current shunt feedback. In their voltage series feedback, increase input impedance and decrease output impedance. Another one is voltage shunt feedback, in that decreases input impedance and decreases output impedance. Current series feedback increases input impedance, increases output impedance. And current shunt feedback decreases input impedance and increases output impedance. These are the four feedback topology circuit diagrams, ma'am. In series feedback topology, the output signal is fed back in series with the output, with series into the input. This configuration typically increases at input impedance and reduces the output impedance. In this, often used in voltage amplifiers to improve gain stability and linearity. In shunt feedback topology. In shunt feedback topology involves feeding back a portion of the output signal in parallel within the input. It generally decreases input impedance and while increasing output impedance. It is commonly used in current amplifiers to stabilize gain and bandwidth. In voltage feedback feeds back a voltage in series with the input. In this topology enhances gain stability and reduces distortion. It is widely applied in audio and instrumentation amplifiers. In the current shunt feedback feeds back a current signal in current parallel with the input. It provides high input impedance and low output impedance, unsuitable for current amplifiers and applications requiring impedance matching. Is the comparison between series and shunt feedback. Series feedback tends to increase input impedance, while shunt feedback is decreases it. Both topologies can improve linearity and both topologies can improve bandwidth, but in different ways. This choice depends on the desired input or output impedance, characteristics, and system stability. In these four types of feedback topologies, advantages, ma'am. Feedback topology improves system stability and linearity. They help reduce distortion and noise in the overall system. Feedback can also extend the bandwidth of amplifiers and control systems. In these limitations and challenges, excessive feedback can lead to reduced gain or instability. Implementation may introduce complexity and cost in circuits and circuit design, and proper analysis is necessary to avoid oscillations and ensure desired performances. In practical applications in the feedback topologies are used in only audio systems, communications, and instrumentations, etc. They are critical in power amplifiers, sensors, and control systems for precision. Understanding these configuration aids engineers and in optimizing system designs. Thank you for giving this opportunity, man.